Hello everyone, my name is Eric Severy and I'm a graduate student at Seoul National University. This is a video series I'm creating on computational science with Python, Matlab, and C++. Alright, what is computational science? It is really just computing for science. It sounds very simple. It's not computer science. Computer science is the science of computers. Computational science is using a computer to do science. The goal of this course, we're going to start by learning programming through Python, C++, and Matlab. We're also going to cover the basics and foundations required for more advanced topics in computational science. My motivating force for creating this video series is that when I'm teaching a computational science course, I get these students who will come in and they've studied something in Python, but for the course we're teaching, we're using C++. And there tends to be a really slow transition from Python to C++. They just have to learn C++ from scratch. And my goal here is, well, if I'm teaching C++ and you know Python, I want that transition to be quick and easy, and I want you to have resources that you can go back to. As a computational scientist, I use Python, C++, and Matlab all the time. I think they're the three cornerstones. If you understand those, then you can go to any other language or tool and work with them pretty efficiently. If you know C++ and then you have to go work in Fortran, that's going to be easier than if you don't know C++ and you only know Python. If you know MATLAB and you use MATLAB for visualization, using other visualization tools will be easier. Or if you program in MATLAB, then you're going to be able to go to other Mathematica software and use that a little bit more naturally. So that's kind of the goal here. So we're going to cover just some cores for computational science, and I know these aren't the only tools you need, but from these core tools, I think we can branch out and do a lot. And hopefully by the end of this, if people go through all the videos, they'll have the core foundations that are required for more advanced topics. One of the ways we're going to be learning is by comparing languages. When we compare things, it leads to deeper understanding. I'm teaching a course in Seoul, South Korea, and I learned Korean by comparing Korean words to English words, or comparing Korean words to Japanese words or Chinese words. And through this comparison, I learn a lot, even comparing words to other words we know. Same thing in computer languages. When we compare languages to other languages we know, we learn more. So if we just look at Python, we don't know what Python is missing. But if we look at Python and C++, we start to see, oh, Python doesn't deal with typing, but we do in C++, and it gives us a slow advantage in C++, or it gives us an advantage in Python. There are times when it's an advantage, sometimes when it isn't. And by looking at what a language has and what a language doesn't have, I hope we'll have greater understanding of how the programming languages work. I honestly don't think any language is better than the other, Python, C++, or MATLAB, but I do think some of them are better for certain applications. I've written programs in C++ that would be nearly impossible or just really difficult to work with in Python just because of how the languages work. So we're also going to be combining languages. It's a very common practice to use different languages together. I've worked with a lot of software which will have Python for the user interface and Fortran doing the computation in the background. Or I will do my computation with C++ and then visualize it with MATLAB or Python. So we can break our program up into different parts and use the most efficient language for each part that we're using. In fact, sometimes people even combine everything into the program itself. Currently, I create data files and then I just load the data files into another language. Alright, so our goal here is to cover the foundations of computational science. When we do computational science, we need to understand math, computing, and science. Most students are lacking in one of these areas, and I actually find that the computing is the area that tends to be the most detrimental to learning computational science, because a lot of people, they know the math they need for what they have to do, and they know the science for what they have to do, but the computing is where it gets tricky. Now, as these videos progress, we are going to get into all three topics, but in the beginning, I'm going to really start with computing and making sure people understand the programming language. In university, everyone should know calculus, so you know the basics of math. Everyone should know physics, you know the basics of science. But not everybody learns computing, so we're going to start to make sure we get everyone to a common framework for computing. And that way we can get everyone to the same page and then progress forward. So yeah, we're going to start out focusing on the computing, the programming, and as we go, we're going to talk more about mathematical and scientific concepts. So with these videos, I have a few goals. I want to keep the videos short. 5 to 10 minutes per video is all I want to do. Now, it may take me several videos to get through some of the more advanced topics, but I'm going to try to break those up into small chunks, just so that you can digest them in a small, discrete portion. We're also going to I'm going to try to use different videos for C++, Matlab, and Python. You might be using C++ for your course, and you don't care about what we're doing in Matlab. So I'm going to separate these out because I don't want you to have to try to scroll or go halfway through a video just to find the C++ portion. Now, sometimes I will combine different topics because either A, they'll be really, really short. When I'm talking about different types of variables, I could probably talk about all 3 languages in 5 minutes. Otherwise, I might be combining them to say, hey, this is how this works in Python, this is how this works in C++. It's an interesting comparison to think about. That might kind of be more a supplemental video, but in general, I'll keep the video separate and then combine them if there's something interesting or if they're very fast. And then just to kind of get started, I am TAing a course this semester, and I just think for efficiency and for my current students, I'm going to just start by following the curriculum for the course I'm TAing right now. Now, the course I'm doing is focused on Python, so I might actually get ahead on Python videos and then go back and redo some of those with C++ later. But through the playlist and things like that, once everything is finished, it should all play well. So I hope these videos are useful to someone, and I hope I can do something interesting and enjoyable. But I'm going to get started with making my actual content now, and I hope you enjoy these videos. Thank you.